Good morning everyone. In this video lecture, we are trying to learn what is the free body diagram and how to draw the free body diagram and for the different engineering applications. So, some of the topics are going to be very essential to draw the free body diagram. The first one is going to be the constraints. One should have to know what is the constraint. The constraints are nothing but which try to restrict the free motion of your body is called the constraints. It means that we are intentionally providing the restrictions to the motion of the body to perform exactly to get the performance. And the second one, the types of supports and type of reactions. In this case, already we told the restrictions we are providing to the free motion of your body. In this case, that restrictions are going to be coming in terms of types of supports. And if you stop that motion of your body, it will generate the reactions. That reactions are going to be coming from these supports. That's we can say the support reactions are coming. Next one, principle of transmissibility of a force. So without changing the equilibrium of a body, either maybe at rest condition or in the motion, so we need to change the force position from one point to other point on the line of action. Then we can say that is the transmissibility of the force. So in this video, specifically we are talking about the free body diagram. So I would like to define what is the free body diagram. So the free body diagram, to draw the free body diagram of a body, we remove all the supports like walls, floor, hinge or any other contact body and replace them with the reactions which these supports exert on the body. So as we know that the engineering bodies or engineering structures are going to be supported by the many things. Just like a floor, suppose you can take the building. It is going to be how it's the foundation and the pillars and the roof and walls, everything we do have. So in this case, if you want to draw the free body diagram, so then we need to remove all the supports which are going to be coming in terms of different contacts. So then we are going to replace them by the reactions which these supports exerts on the body. That means what is the contact body is going to be exerting the same some results. The same results also we are getting from the reaction forces. So here that the reactions, that means the replace them by the reactions. Here the reactions may be in terms of we are getting the external forces as well as the internal forces of the body. Here what is the external force? So in this case the external force, these are the forces which acts on a body or a system of bodies from the outside. For this one, I would like to take one example. Horizontal plane I have taken, the frictionless horizontal plane I have taken, and a sphere is going to be mounted. That means they kept on the horizontal surface. Then there is a string or the rope is going to be connected from the center of the sphere to the ground. That means the horizontal plane at A. AC is going to be ours, the rope or the string which is trying to provide the restrictions to the forward direction towards the right side. When I am going to applying the force P, the body is trying to move in the forward directions. Then what will happen? Because of the C, it's trying to restrict the motion. So what are the external forces acting on a given body? So in this case, the same diagram I am representing here, that's going to be A is the point where the string is going to be stick. So then I was applied the force in the direction of the P. Then what will, in this case, what will happen? That AC and the sphere is going to be considered as a single unit. That is called a system of bodies. If I am going to consider only the sphere, that is one body, and the string is the one body. But in this case, these two are combinedly, we can say, that is the system of the bodies. So then the load P is going to be acted towards the right side. Then because of this force, the body is going to be trying to move towards the right side direction, including with the string. So then what will happen in this case? So because of this AC and B is going to be the internal system. So then the self weight is going to be acting in the downward direction. This is the second force from that body. And the next one is going to be the reaction force is coming from the horizontal plane. So where it is going to be trying to oppose the weight of the body in the downward direction. That means here the RB is going to be providing the restrictions to the move in the downward direction. So then there is a reaction force is going to be developing. But AC also has the tension, but that is going to be included. So that means AC and the sphere is only the one unit. That internal forces we are not going to show as external force. So these the force P and the self weight and the RB are going to be at the point C. So here is the forces, weight of the roller, applied force, the reactions RB at the point of the contact. These three forces are going to be considered as the external forces. Then what is the internal forces? So that we are going to be discussing here. What is the internal forces here? These forces which hold together the particles of a body, right? Suppose the before problem we have seen the sphere and the string are going to be attached. So in this case what will happen, the string is going to be trying to pull back that sphere at the equilibrium position even though the force P is going to be applied. Then that tension force we are going to be called the internal force of the system. So then the examples I am going to be giving here graphically, and AB is going to be the one of the prismatic bar. This is consist of a circular or maybe the square, whatever it may be. Then the force I was applied at A, that's going to be the F force I was applied. Then what will happen, the body is trying to move towards the left side, and similarly at B we are applying the another force at F. Then what will happen, the body is going to be in the equilibrium condition. It means that these two forces are in the same magnitude in the opposite directions. At the same time the body is going to be subjected to the tensile forces. But actually that particles, the AB is going to be composed of the matter. It's trying to separate because of these forces. But to resist that part, there is going to be internal forces are going to be generating. That is going to be that shown with the S and the black arrowheads. So then what will happen, the body is going to be trying, that is the coherent force is going to be acting inside the member. It's trying to pull towards the its equilibrium position of the every particle. So then in this case what will happen, what is the external force F is applied, at the same the internal force S also equal in magnitude but in the opposite direction. It is very clear that external force is in the tensile directions but internal forces are in the compressive direction. So if we try to pull the bar by applying the two equal and opposite forces, then internal forces S comes into play to hold the body together. This is the way we are defining the internal forces. The next, what is the internal forces in this case? And the before case we have seen only the one body, that is the prismatic bar. In this case system of bodies we are going to be taking, and if more than one body is involved, means the bodies are going to be interconnected. Just suppose you can take a rails. In the railway system what will happen, these railway bogies are going to be interconnected each other. It means that the system of the forces are going to be connected and they are going to be considered as a single unit. But it is going to be composed of number of, the bogies is the number of masses. That means more than one body is involved. It may be the force that holds the two bodies together. That is the force it must be hold. So here I have taken one inclined plane that's shown in the green color. At the same time two masses A and B I have taken, and AB is going to be connected with the string, and from the B to the pulley and F force was applied towards the right side in the downward direction. So then what will happen in this case? So which force is going to be holding these two bodies together? That's going to be the A between the string AB or after the string. So that's we can see here. So there is going to be two masses A and B, and then what will happen in this case, the self weight is going to be acting in the downward direction, then automatically the body is going to be trying to move in the downward direction, but the F force we applied. So then what will happen, there is a tension existed in the string between the A and B string. So that force we are going to be say the internal force, and the T is equal to F we are going to say that force after the B towards the right side, that force is going to be called the external force. Only the T between A and B, T is going to be our internal force. So if two bodies A and B are connected by a string or hold in an inclined plane by a force F, then the force of the tension T in the string is the internal force. So next, internal forces. But if you consider the equilibrium of a single body, suppose in two bodies we have taken A and B. Now we are considering only the single body A. This force tension T becomes the external force acting on the body. So there we can see this is going to be the mass which is inclined and the A. So then what happens, self weight is going to be acting in the downward direction. This is also become the external force over here. And the next one, the tension between in the string between the A and B is going to be the T, that is also become external force, and the R is going to be the reaction force from the inclined plane to the point of contact of the mass A, then that is the R.